Let's talk about powers. A to power b means that we take the number a and we multiply it together with itself b times. So for example, 2 to power 3 is 2 times 2 times 2. There are in total 3 of these factors here. We would get 8. 2 to power 2 is 2 times 2, that is 4. 2 to power 1 is just 1, 2. And we can see where it is going. We are dividing by 2 when we are reducing the exponent. So we see that 2 to power 0 is, we have to divide 2 by 2, it is 1. Actually, any real number to power 0 is 1, except the number should not be 0. Let's practice by calculating some powers of 2. Let's make a table with numbers n and 2 to power n. We'll already know that 2 to power 0 is 1, 2 to power 1 is 2, 2 to power 2 is 4, and 2 to power 3 is 8. 2 to power 4 would be something like this. This is 8. 2 times 8 is 16. Multiplying 16 by 2 we would get 32. Multiplying 32 by 2 would give 64. (64 times 2 would give 128. Multiplying that by 2 would give 256. Multiplying by 2 we get 512. And 2 to power 10 is 1024. About 1000. This number is important if you are talking about some binary numbers like megabytes and kilobytes and converting them into each other. Let's calculate a few numbers more. It seems that our calculation rules will be useful in this. Let's see. What is 2 to power 11? It would be 2 times 1024. We can make the calculation more easy by representing 1024 as 1000 plus 25 minus 1. Making the calculation we get 2000. 2 times 25 is 50. And 2 times minus 1 is 2. Here we use the distributive law. So the result is 2048. In the same way, 2 to power 12 is, maybe we do it in this way. Let's take the same representation. We would get 4000. 4 times 25 is 100 and minus 4. These are together 96, so we get 4096. 2 to power 12 is 8 times something like this. By using the distributive law, we get our answer quite easily. let's use the definition of powers to make some rules for powers. If you would have 5 to power 3 to power 2, this would mean that we take the number 5 to power 3 and multiply 2 times with itself. So if this is here is a, then this here is a times a. Well, what is this? We can express 5 to power 3 as this product, and we can calculate that in total there are 6 of the factors, so we get that this is the same as 5 to power 6. From here we can guess that we have some calculation rule that a to power b in brackets to power c is a to power b times c. How much is 2 to power 3 to power 2? Well, that is 2 to power 3 times 2. It's 2 to power 6. Let's check from our table. It is 64. What is 2 to power 3 to power 2? Well, this power here seems to be 9. 3 times 3 is 9. So we can check our table. 2 to power 9 is 512. So if we write some numbers like this, it's a little bit dangerous because the brackets can be in this way or in this way. We should make clear what we mean. By using the same procedure, writing everything open, we can find many other calculation rules of powers. If we have some simplification task, we can use these rules, or we can use the definition of the power. For example, if we need to simplify this, we can proceed in 2 ways. Well, we have the rule that if we have a product and that is to some power, we need to make both of the factors to the same power. So by using this rule we would get b to power 3 and a squared to power 3 and now a to power 2 to power 3 is a to power 2 times 3, that is a to power 6. Like this. And in total we have a to power 7, b to power 3 over a squared b. And now we can cancel out. For cancellation we can use these rules. So it seems that we will have a to power 5 and b to power 2. This was one way how we got the answer. We can calculate the task also by just using the definition of power. Well, it seems that we can cancel out some b's and cancel out some 2's, and in the end we will have a how many times? Here we have 1a, here we have 2 and 2, so in total we have 5 a's, and b's we have just 1 and 2 here. So that would be our result. we didn't have to use any rules for powers, but we could just write up what is the definition here.